students, and welcome to lecture 9.3, graphing linear equations with two variables. So if you recall about graphing ordered pairs, so ordered pairs are a set of two numbers. The first number is always the x-coordinate and the second number is always the y-coordinate. You would start at the origin for, let's say, point A, and I go left and right none, but I go up 3. So my point A is at 0, 3. B is -2, -4. Starting at the origin, I go to the left 2, and then down 4, and that's where I plot my point. C, I start at the origin, and I go to the left 5, and I go up 1. And then I'll let you just pause the video and look at every single one of these points and see where it's plotted and get used to where everything is plotted. Now that we're familiarized with plotting points and plotting ordered pairs, we're not going to start graphing linear equations with two variables. What I mean by that is something like x plus y equals 5. Now for every x you can throw at me, I can come up with a y. At least if it's a rational number, I can come up with a y. So if it's 2 plus something equals 5, so 2 plus 3 will give me 5, so the point will be 2, 3. Likewise, if y is, let's say, -10, I can come up with a number, 15. That 15 plus -10 will give me 5. So again, any number that you can give me, I can come up with a corresponding value. So how do we graph linear equations? Well, we're going to graph a couple of the solutions, and from there we're going to connect the points. So here I've done one for you. I chose 0, 2, and -1. So when I place 0 in, 0 plus something gives me 5. It must be y must equal 5. Then I chose 2. 2 plus y gives me 5. Subtract 2, so y equals 3. When x equals -1, add 1 to each side, so y will be 6. And then I go over to my graph and I plot each of those points. So 0, 5, 2, 3, and -1, 6. And by using those points, I'm going to take a very nice edge, like a ruler, and then I'm going to connect those dots, and I'm going to do it the best that I can. And what I want is I want to run through the numbers, creating a line, and then putting an arrow at the end of each end of our line, and that will give us every single solution that fits this equation. It's a line. It's not only the whole numbers, it's everything in between, hence doing a line. Solutions are straight lines. We have something called the linear equation in a standard form. Any equation that can be written in the form of ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. One can be 0, but not both of them, is called a linear equation in two variables. The form ax plus by equals c is called the standard form. Here's how we graph a linear equation in two variables. Remember, we're graphing every single solution that fits this linear equation. Step 1 is to find any 3 ordered pairs that satisfy the equation. These are to you. I mean, you can choose which ones that you want to choose. So let's say I can choose x is 100, and then I'll find the y value. Be reasonable and be clever about it, and then you'll pick good numbers to plot. And in math, that won't be too difficult. But you want to find any 3 ordered pairs that satisfy the equation. You want to graph the ordered pairs. You need 2 points, but the third is a checkpoint. Then you're going to draw a straight line connecting the plotted points, and at the end of that straight line, you're going to draw arrows. Here's an example that I've worked out for you. So x equals 3x minus 1. The standard form, just for information purposes, the standard form would be -3x plus y equals 1. use the equation that we're given, y equals 3x minus 1, just fine to find our solutions. That is not in standard form. The standard form would be negative 3x plus y equals negative 1. So the points, the x values I'm going to choose are 2, 0, and negative 2. So by plugging in 2 wherever I see an x, y equals 3 times 2 minus 1. That will give me a 5. So when x is 2, y is 5. When x is 0, 0 minus 1 is negative 1. So y will be negative 1. When x is negative 2, 3 times negative 2 minus 1 is negative 6 minus 1, which is negative 7. So each of these ordered pairs, 2, 5, 0, negative 1, negative 2, 7, I'm going to plot. So starting at the origin, 2, 5, I move over 2 and up 5, over to the right 2 and up 5. For 0, 1, I stay where I am. I don't move left or right any, but I do go down 1 and plot my point. Starting back at the origin for negative 2, negative 7, I go to the left 2 and then down 7. I have 3 points. I pull out a ruler for a nice straight edge, and I connect the points and add my arrows, signifying that my line never stops. And those are all of my solutions to the equation y equals 3x minus 1. Now I did say before you can choose any numbers, but sometimes you do want to be clever about it so your math is a little bit easier. For example, I want to graph y equals negative 1/3 x plus 2. Now if I choose 1, I'm going to have to deal with a fraction. But if I choose a value of 3, then this negative 1/3 times 3 will become a whole number. So choosing plus 3, or positive 3, negative 3, positive 6, negative 6, 0, that will get rid of the fraction. All of those points are great points to, or a great x-coordinate to use so you get whole numbers in the end. So I'm going to use 3, 0, and negative 3. Again, 2 points will get me a line, but 3 will make sure I'm on the line. So y equals negative 3 times 3 plus 2. That is negative 1 plus 2 equals 1. So my point is 3, 1. So starting at the 0, move over to the right 3 and up 1. Next point. Y equals negative 1/3 times 0 plus 2. 0 plus 2 is 2. How about that? That is 2. So I don't go left or right any, but I do go up 2. Last one, y equals negative 1/3 times negative 3 plus 2. Well, negative 1/3 times negative 3 is positive 1. 1 plus 2 is 3. So starting at 0, I go to the left 3 and up 3. Now that I have my points, grab my nice ruler and make a nice straight edge. Again, arrows at the ends. So here's a class problem you can try. I want you to graph 3x minus 2 equals 6. You don't have to be too careful about which x or y value you choose, but you do want to pick fairly simple ones. Maybe you don't want a 10 or a 20. Pick something small. You need at least 3 points, 3 values so you can find 3 ordered pairs, create your graph, and plot them and connect them. So I'd like to see that in our next class period. Now I'm going to graph 3 lines, or I have graphed 3 lines, and these 3 lines are actually very special lines. The first one is in the equation y equals negative 1/2 x. So I just chose 3 points on the line and I graphed it. So off to the side I said, when x is 0, y is 0. When x is 2, y is 1. When x is negative 2, y is negative 1. With those 3 points, I plotted it. I graphed it. The next line, x equals 3. Now you can think of this when x equals 3, it's really x plus 0, y equals 3. So you can choose any value for y this true. So let's say y is 1. Well, when y is 1, x equals 3. When y is 2, x equals 3. When y is 10, x equals 3. So no matter what y is, x equals 3. In that case, I plot a few points, and it is a vertical line. It's called a vertical line. It's like a wall. C is y equals negative 2. So just for example, y equals negative 2. That's the same thing as saying 0x plus y equals negative 2. So choose anything for x. I'm going to say 5. When x is 5, y is negative 2. So when x is 5, y is negative 2. When x is 0, y is negative 2. When x is negative 8, y is negative 2. So no matter what x is, y is always negative 2, and therefore it's a horizontal line. So these three are very special. The first one, although it didn't really look special, it was going through the origin. It's going to in the very middle of our graph. So if it's going downward, then it's going to be in some type of form where it's y equals a negative number in front of x. So y equals negative m, whatever that m is, x. When it's going upward through the origin, it's going to be y equals mx, where m is any positive number. When it is a vertical line, it's going to be in the form of x equals a. It's going to be on the right-hand side of the y-axis. And if it's a negative number, it's going to be on the left-hand side of the y-axis. When it is a horizontal line, that means y equals a number. If it is a positive number, it's above the x-axis, and when it's a negative number, it's below the x-axis. So just as a recap, when it goes through the origin, it's going to be in the form of y equals some value in front of x. When it's a vertical line, it's x equals a number. And when it's a horizontal line, it's y equals a number. Now, I don't ask you to memorize a lot of stuff, but I do think that you should memorize this to make your life a little bit easier to recognize when it's a vertical line, when it's a horizontal line, and when it goes through the origin. So that's it for this lecture. Until next time, be seeing you.